All right, babe. Okay, so first of all, I've already reviewed type 1 and type 2, so I don't feel like I'm doing that again, but I will. As a matter of fact, Tuesday after school, I'll have a help session just for chemistry. So if you would like to be there at the help session, I'll be there for you. All right. Well, what we notice is that what makes this different than type 1 and 2? Can anybody raise your hand and say, I know what's different there? What's different, you know?
It's not binary.
It's not binary. And I have some good news for you. If it's not binary, it contains a cluster of atoms that are bonded together who act like an ion. They have a charge. And, wait, you shouldn't answer that one. I'm calling somebody else. What do you think? Polyatomic ion. And that's why we have to memorize those. Now, those are not compounds. They are bonded together, but their net charge is not zero, is it? That's a compound. So we have another name for them. They're called polyatomic ions. Now, this one has many atoms in it, but it acts like my fist. It acts like a single ion with a -1 charge, doesn't it? So if this is +1 and nitrate is -1, I only need 1 nitrate and 1 sodium, and I have sodium nitrate, don't I? That's pretty easy. Now let's go over here. Let's go the other way. Let me give you the name, and let's do it not with a type 1, not with an always metal. Not an always metal. Let's pick a metal that's not an always metal, like copper. And again, I will tell you on the periodic table, I will tell you that copper comes in +1 and +2. I will tell you that the Latin name for copper is cuprum. I'll tell you all that, so you don't have to worry about memorizing that. You have your hands full in memorizing the polyatomic ions, don't you? So I'll help you there. All right, so if somebody says copper 1 nitrate, then what I'm going to do is we're going to write copper 1, because you told me it was copper 1, right? And then nitrate. Does anybody happen to memorize nitrate yet? 1, 2 of you? Anybody else? You have? What's nitrate? What's charge?
Is it
If you had to guess, there's more what? What's the most? -1, -2, -3, or +1? Oh, there's only one +1. That's ammonium. Okay, anyways, -1, okay? But anyway, nitrate is NO3. You had that right. But it's a -1 charge. So now, this is +1, this is -1. I don't think I need to do anything, do I? And so I just take one of each, and there we go. Copper 1 nitrate is written like that. But now, if we had to go copper 2 nitrate, then I'd go, oh, you said copper 2? There's copper 2. But you said nitrate was NO3, and you said the whole thing called nitrate had what charge? Well, that's not going to work. You can't have +2 here, -1. So do I need more of the sodiums, or I need more nitrates? All right, Claire, what do you think? Do I need more coppers or more nitrates? And how many total nitrates would you like to have? 2. And the only time you use a parentheses when you do a chemical formula, let's see if Victoria can help me, Victoria. The only time I use parentheses in a formula is when I need more than 1 what? More than 1, what's this thing called? Yes. Everybody get that? If you need more than 1 polyatomic ion, you have to put parentheses in there. Get that? All right. The other thing you taught, and this was in the video on Wednesday, and also I taught it again yesterday, so you can watch the video now if you want. But they had a system before they started using the Roman numeral. This is called the stock naming system. And they thought that these metals that could do more than one thing, they thought they only could do 2 things. And so they said, well, I know how to fix that. We'll use the ick and us system. And so my picture that you saw on here, the big icky monster, it simply said copper comes in +1 and +2. And so who's bigger? 2 is bigger than 1. So he's the big icky monster. The Latin name is cuprum. So you'd be called the cupric ion and the cuprous. And again, you know what? If they were not still using that old naming system, there was no way I would take the time to teach it to you. Get it? But it's still there. When you go to college, it's going to be there. And so I want to teach it to you. So what's another name for copper 2 nitrate? Ooh, you're the big icky copper, aren't you? Cupric nitrate. Notice that when I use the ick and us, I do not also use the Roman numeral, do I? Okay, does everybody get that? Don't put cupric 2. Don't do that. Okay, how about this guy? He's copper, not the big icky monster, cuprous nitrate. Has everybody got that? Well, that's really how you do type 3. Now, if you have your homework, if you have your homework sheet with you, I thought we would do a couple of those. And did we do these yesterday? Did we do some of these yesterday? Okay. Why don't we do, let's go over here. And I don't know why, I guess when I copied it, you ever understand you don't have to do the same page twice? Oh, everybody get that? I don't know how that happened. I guess I copied it wrong. That's today's lesson. Here we go. We'll go over here. And why don't we try one when I go through here, when I scan through here, how about this guy, calcium chloride? How do you think you do that? Well, the good news, when I see calcium, I automatically know he's what? What is calcium? What's the good news about calcium? What is he? Always metal. I don't have to worry about Roman numerals. You get it? I'm not going to use Roman numerals for those. There's only one way. Calcium's always +2, isn't he? And what about chlorine? What about chlorine? What do you think? Look up here. What about these guys? What are they going to be in a compound? Everybody. What are the halogens? What do you think? John, what do you think? In a compound, what are the halogens? What charge? The halogens? Remember you did that little -1. So we'll put a chlorine here with -1, and you say, well, hey, that's not right. That doesn't add up to 0. You can't be a compound. So I need 2 of you, don't I? And 2 times -1 is -2. I think we have a compound there. That was an easy one because it wasn't always metal, wasn't it? Yes, Claire.
Do we have to write the charges, or can we just
Okay, I'm not going to count it off if you do that. Your final answer, normally in a book, you will never see those little plus and minus things. But I don't want to be picky and count off points because you left them on there, okay? Is that right? Okay, so honestly, this is the way you should write it, but I'm okay if you leave those on there. That's a good question you had. Well, let's do one that you know is not an always metal. Why don't we go down to, I'll go up here, I guess. Let's do this one. All right, everybody do that. Take 30 seconds and say, you know what? I'm going to do that in less than 30 seconds. Number 3, iron 3 oxide. All right, go. Push yourself, say, oh, I can do that. I can do that in 15 seconds. All right, time's up. If you don't have it done by now, that means I think you're a little bit behind where I'd like you to be, okay? The first thing I would have done is I would have written Fe and O. Did you get, there were 2 elements, right? And it ends in IDE, we know it's binary. And so it said iron 3. That Roman numeral, you should have automatically done that. Did everybody do that? You look on the periodic table, oxygen is -2. And whenever you get an odd even number like this, the smallest number they both go into is 6. 2 times 3 is 6. 3 times 2 is 6. Plus 6, minus 6. What do you think? Yes, I've done these many, many times. I'm going to be faster than you, but what is it that slowed you down? If you couldn't do it in 30 seconds, what is it that, think about it, what is it that slowed you down, all right? Now, I'm going to give you 30 seconds to tell me the other name of this compound. What is the other name of this compound? And I will tell you that iron comes in +2, and iron comes in +3, and I will tell you that the Latin name is ferrum. All right, ready? Go, 30 seconds. What's the other name of this compound? And don't say it yet. I'm going to give everybody 30 seconds, remember? I'm okay if you're sitting there and you said, I don't know. I'm glad if today's the day you said, I don't know what to do, then I'm glad. Because now you know what it is you don't know. Is that right? Okay, so now, let's stop. This guy was Iron 3, wasn't he? He's the big, icky monster, isn't he? So, the other name for that, and you know. Yes. Ferric oxide. What do you think? And again, I'm okay if you sat there and said, "No, I got stuck there." At least you know that's something you didn't know how to do, right? You know what you don't know how to do. All right. Well, anyway, that's type 1, 2, and 3. Yes.
Yeah. So for that one, can you give when you actually found the answer, it would be Fe2O3.
Yeah. The final answer, without seeing the plus and minuses, would be Fe2O3. Right. And again, I'm not going to count off points if you leave those up there, but it's okay with me at this point. You guys are just starting out, aren't you? There's no way next chapter that I'd like to have them gone by next chapter. But this chapter, I could see you leaving the plus and minuses up there. All right, what do you think? All right, so now what I have is to finish out all of this, we're going to do type 4 and 5. And so I'm going to go back to the teaching packet. And let's go to, there it goes. Now, on type 4, there's a group of compounds that act a little differently than others, and I didn't do it, but they decided they were going to have a little bit different naming system for this group of this compounds. Okay, now they're called acids. They don't have a different name for naming bases. Bases are like sodium hydroxide, potassium hydroxide. They have hydroxides in them. Okay. And so they don't have a separate name for that, but they do have a separate way of naming acids. And so I'm going to try to show you in about 10 minutes what is the pattern for naming any acid. And if you know the pattern, I can show you some. You'll be able to name them all. I think you'll be able to name them all, okay? Okay, number 1. Acids are always written, and you'll find H is the first thing that's written. Now, there are 2 exceptions. Water has H written first, and hydrogen peroxide does also. Now, these 2 are the only 2 I can think of that start with H, but they're not acids. You get that? Now, from that point on, except for these 2, if you see something like this, if you see HCl, H2SO4, you know that you have to name it like an acid because they wrote the hydrogen first. Now, what you're going to find out later is when you put acids in water, this guy here, this ion, hydrogen ion, it comes off. And that's what makes an acid an acid. When the hydrogen ion comes off, it acts like an acid. And that's why he's the star of the show. Hydrogen is the star of the acid world. And that's why all acids have the hydrogen written first. You okay with this? So if I were going to take a test, here's what I might suggest. I might suggest to you that you do all the acids first because you have to name them like acids. Get that? And I'll probably put that on the test. I'll say, here's my suggestion. Do the acids first or else you'll forget to name them like acids. Well, how do you name them like acids? Okay, so here's what I do. In my mind, I have all acids in my head. And then the way you name it, I'm going to branch it off. And what are the branches here? Now, if you're an acid and you have no oxygen in it, no oxygen, then I'll show you how to name those. But then there are acids that do have oxygen in it. Matter of fact, they have a fancy name called oxyacids. Oxyacids have oxygen in them. These acids have no oxygen. And I'm going to show you an example. The best example is this right here. The most famous acid in the world. It's in your stomach. Okay? Does anybody know what this is called? Have you ever heard the name of this acid? Yes.
Citric acid.
That's right. So watch, this is my model. Now notice that an acid with no oxygen, what's the first thing that came out of your mouth? Hydro. See that? Any acid that does not have oxygen, you start with hydro. Now you leave a blank, and you end with ick. Now what goes in here? What goes in here? Excuse me. What goes in here, you think? See that element right there? See, this is a cation, this is the anion, isn't that what goes in there? All right, instead of saying chlorine, they say okay. Chlor, right? So hydrochloric acid. Now, I know you think that sounds too simple, but watch what I just did. If you could name that acid, then tell me what the name of this acid would be. What's HBr? Will, try that one. Will, HBr. Same pattern. Say it again. Yes, that's exactly right. Okay. Let's have, let's see. Todd, how about this one? HI. Iotic, hydroiodic. All right, very good. Eloise, how about this one? H2S. It's hydrosulfuric acid. You with me? And the last one would be hydrofluoric acid. You say, wow, that wasn't so bad, was it? If I remember HCl, I'll remember how to do all the acids that don't have oxygen. I'm looking at your faces, okay? Now, the ones that do have oxygen are just a little bit harder, a little bit. But let me show you some great examples here. HNO3, HNO2. Now, both of those are acids. How do I know it? It starts with hydrogen, doesn't it? But these acids have oxygen in them. Ooh, you know why they have oxygen? Because they have a polyatomic ion in them that has oxygen. Aha! Aha! Now, what's another reason why you have to know your polyatomic ions? Because these acids, you need to know the name of the polyatomic ion. Now, everybody see this? All right. What is the name of that polyatomic ion? You happen to know that one? It's one we use for examples today. All right, don't say it out loud. Raise your hand if you know that. We know it? You know it? You know it? All right, who doesn't know it? Okay, I can call it any of you? Okay. Okay. Andrew, what is NO3, the -1 charge? Okay, so make sure you raise your hand so I know, okay? Nitrate, isn't it? Now watch. If the polyatomic ion ended in ATE, and it did, didn't it? Because nitrate, he is the famous nitric acid. Now watch what happens here. I'll show you a little trick here, a little memory trick. What is the name of this polyatomic ion? Oh, NO3 was nitrate. NO2, Claire, remember yesterday? Say it again. Nitrite. You guys are good. So if it ends in ite, if the polyatomic ends in ite, then you don't get to become the famous ick acid. You're the lesser known us acid. Oh, wait a minute. Ooh, memory trick. You had more oxygens than me. You're the big icky acid. Oh, I can use that memory trick again. Yes? So I have two acids. One has NO3, one has NO2. Is that right? Who's the big icky polyatomic ion? NO3 or NO2? Oh, NO3. Then you're nitric. Now, the biggest mistake people make is you want to use hydro. No. When's the only time you use hydro? Huh? Acids at what? No oxygen. I don't use that very often. I don't use hydro very often. What's this called? Nitrate is the famous nitric acid. Nitrite is the nitrous acid. If you'll learn these three, you'll know how to do any acid I give you. Any. Now, you have to know your polyatomic ions, don't you? And I'll help you with that too. So I'm going to show you, I'm going to flip this over, and we're going to do some acids, and let's see what happens. Let's do this one here. H2SO4, H2SO3. All right, everybody ready? All right, let's see if you can name that. See if you can name these. Now, I'll help you a little bit. Do you know that SO4 is called sulfate? And SO3 is called sulfite. Okay, go ahead. See if you can name these oxyacids. Remember, you're not going to use hydro for these, are you? You notice how I kept this to the end because I knew it wouldn't take as long to learn these. And the next one's type 5. It won't take very long at all. Okay, let's everybody stop. And the first thing you notice is it started with H, so I have to name it like an acid, don't I? Now, I'm not going to say hydro because he has oxygen. So I'm going to say, hey, what is the name of that polyatomic ion? Sulfate. Right? Okay, so, Maddie, what do you think? Give me a name for this guy.
Sulfuric acid.
Yes, sulfuric acid, right? Matter of fact, he was the big, icky sulfate. He was bigger than sulfite, wasn't he? Okay, let's have Finley. What's the name of this acid? He ends in ite, sulfite.
And that'd be,
Are you with me, Finley?
yes, it'd be sulfurous acid.
Now, we already had sulfuric acid.
Sulfurous.
Sulfurous, uh-huh.
Yes.
Sulfurous acid. What do you think? Now, I can do the rest of these, but I'm going to show you, I'm going to see how well you can do this, all right? Do everybody know this guy? Does everybody know his name? ClO3, -1 charge? Don't say it out loud. 1, 2, how many people? 3, 4, 5. Oh, that's good. That's good. Ooh, really? All right, what is it, Todd? Yes. Okay, he's one of the famous 8s, isn't he? Now, therefore, if you know chlorate, then you know ClO2, I took away an oxygen, it's called what? This is chlorate. And this is chlorite. And then there's another polyatomic ion, ClO, chlorite. No, that would have been a nice name, but what did they say? It's even less than chlorite. What is it, Will? Hypo, less than chlorite. And in chemistry, when you add an oxygen, I think they should have said hyper, but they didn't. They just said what? Perchlorate, higher than chlorate. Now, why do you think I wrote these down? Not only to help you with your polyatomic ions, but here's what I want you to do. I want you to make an acid out of all of these. And give me the name of the acid. Are you ready? I'll give you 90 seconds. Can you do it? Make acids out of all of those and give me the name for the acid that you make it. I'll give you a clue for the first one. See this guy? Hydrogen's +1 and chlorate's -1. I only need 1 hydrogen, don't I? What's the name of this acid? And it ends in 8. So what am I going to call it? Chloric acid. Big, icky acid. All right, go. You do the rest of them. You do the rest of them. Really, if you can do the chlorate series and make acids out of them and name them, you pretty much know how to name all the oxyacids. Now, this is the first day we've done that. Don't feel bad if you said, "Oh, I can't do that." That's all right. Just try it. If you make a mistake, it's all right. You got this down? You think you got this? Okay, good. Because you seemed like you did it pretty quickly. That's good. I'll give you a clue again. If the polyatomic ends in 8, your acid better end in ic. Isn't that right? If your polyatomic ended in ite, your acid had to end in us. Double check your work. All right, who have I not called on today? Let's see. Oh, Win. I haven't called on Win. I think I called on Victoria. I did. Kieran. Ooh, Kieran and Win. No, Kieran. Oh, he had half an answer. Huh, okay. All right, what do you think? Kieran, give me one. You pick one and tell me the name. What's your favorite one besides the one I did? Okay, so it was called hypochlorite. So hypochlor what?
Chloric acid. Hypochloric.
It would have been ick if it would have ended in 8. But he ended in ite. What happens when, when the polyatomic ends in ite? What happens to the acid's name? Yes. So say it again. Yes. There we go. Yes. See everybody see that? Okay. Win. Which one do you want to do?
Would the last one be hypochloric acid?
Not hypo. What is it?
Would you not put that?
See, there's no hypo in the name, is there?
No. So just
What's the name of that polyatomic ion right here?
perchlorate.
Perchlorate. See, perchlorate. See, chlorate has 3 oxygens. Per means add an oxygen. So this guy's perchlorate, but he ended in 8. So you're going to say what? And you end in 8. The acid has to end in what?
Ick.
So what is it?
Perchlorate.
Yes. Ooh, look at that. That's fancy. Who's next? Olivia. You're going to do the last one. It ends in ite. Yep, you're right. You're right. Do you understand with a little bit of practice, you could get the acids down? What do you think? Now, eventually, you have to know your polyatomic ions, don't you? All right, so you have till Wednesday. You have till Wednesday to learn those polyatomic ions. Hopefully, in class, you'll learn a certain number. Let's get your homework out. I'll help you with your homework. Look at this. There's a whole page for acids. We're going to go right down the row. Todd's going to start. We're going to go ba-boink, 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 ba-boink. Okay? Then we'll go to the next row. And let's see how quickly you can do these. And if you have to look up a polyatomic ion, I can help you a little bit there. We just say, I don't know the polyatomic ion. I'll help you with that. All right. Todd, go ahead. And what do you think the first one is? He's an oxyacid. Yes?
There's like 4 pages that repeat.
If anything repeats, just don't do it twice. Somehow I must have said two-sided, or I just printed it wrong. So
Yeah, because one of the naming.
yeah,
compounds
I don't think anybody in this room is going to do the same page twice. Are you?
no.
Okay, that's my fault. I'll admit to that mistake. I didn't even notice it. Todd, this is an oxyacid. So you better look at the polyatomic ion. You know what that polyatomic ion is?
Nitrate.
Yes.
There's nitric acid.
Okay, hang on. Ooh, you made that look easy. You made that easy. You are correct. All right, yeah, this is not an oxyacid.
Yeah, so it doesn't have an oxygen, so it's going to be hydro.
Yep, it's the only time you use hydro. And what is it?
Chloride?
Yes? All right, Claire.
Um,
Uh-oh, oxyacid.
sulfuric acid?
What now?
Sulfuric acid?
Yeah, sulfuric, yes. And he has the famous sulfate in him, so sulfuric. This was found in car batteries, sulfuric acid. Okay. Next one, uh-oh. What do you think, Eloise?
Sulfuric acid?
Yes. So, we say it again?
Sulfuric acid?
Ick?
Sulfuric.
Ick? Us. Okay. That's it. That's it. Back up to Win. Uh-oh. Do you know this polyatomic ion? I'll help you with it.
No.
Acetate.
So it would be,
Acetate.
it would end in OUS.
It ends, the polyatomic ends in 8, so the acid has to end in ick.
Oh, AT is,
Acetate.
so acid.
Say it.
Okay.
Acetic, uh-huh.
Acetic acid.
Acetic acid is found in vinegar. 5% of vinegar is acetic acid. 95% of vinegar is water. Good job. All right, Claire. Uh-oh. No oxygen. Yes. Hydrobromic acid. All right, Will. Uh-oh, oxyacid.
Nitrous acid.
NO3 is nitrate, but NO2 is nitrite. So if you knew it's nitrite, what did you say the answer was?
Nitrous.
Nitrous? Is that what you said?
Yeah.
Okay. I have a little trouble hearing with the mask and everything. Okay. Next one.
Phosphoric.
Yes. This is phosphate, isn't it? PO4 is phosphate, ends in 8. Phosphoric acid. Wow, you're doing well. Next one.
Would it be hydrosulfuric?
Real loud, sorry.
Hydrosulfuric.
Hydro, there's no oxygen, right? Hydrosulfuric. Oh, wait a minute. I heard that before. No, that's sulfuric. This is hydrosulfuric. See the difference? Okay, next one.
Carbonic acid?
Wow, you that's excellent. That's excellent. This is carbonate, isn't it? CO3 is carbonate, so carbonic acid. You guys are doing very well. Now, I'm not trying to tell you, I'm glad you did that really well, where I write the formula, you come up with a name. That's great. But guess what you also have to do? What if I give you the name, you have to come up with a formula. So we're going to continue, John. Help me out here. How am I going to write the formula? First of all, it doesn't say hydro, so it has oxygen in it. Now, what's the polyatomic ion that I have to have here? What is it? No. What's the name of the polyatomic ion that's in this acid? Because it's sulfuric acid. What is it? Sulfate. Sulfate is in sulfuric acid, isn't it? Do you know the charge, John? Do you know the charge on sulfate? -2. All right. Now, do you know the charge on hydrogen? +1. Now, is this going to work or not? +1, -2? That's not going to work. Yes. See the difference? All right. Let's try it, Andrew. Nitric. What's the famous polyatomic ion found in nitric acid? Nitric has what in it? Yes. What's the charge on nitrate? Yes. So how many hydrogens do I need? Just one. I'm done. All right. Olivia. Hydrochloric acid.
Would it just be HCl?
H is +1 and Cl is what?
-1.
Yeah. Very good. Oh, acetic acid. Acetic acid. What's the famous polyatomic going to be in this guy? what's that polyatomic that goes like this? It goes CHO. Did I tell you that story? Where I did, when I first started teaching, I never did memorize acetate. And I said, well, that's enough. I need to memorize it. And I knew it was CHO. Then I went like this. It's a stupid memory trick, but I never forget it. I go 2, 3, 2. See? 2, 3, 2. Anyway, I never forget acetate now because it's CHO. 2, 3, 2. Anyway, so now the famous polyatomic ion is acetate. What's the charge on acetate? Yep. So how many hydrogens do I need to stick in front of here? That's it. All right, next one.
Would just be HF.
Yep. And hydro, there's no oxygen. Fluorine's -1, hydrogen. Okay, back up to Todd. Wow, you're fast. That was a hard one because it was phosphorus acid, so he didn't have phosphate in him, he had phosphite. And phosphite is PO3. Then you had to remember that phosphite had what charge? -3. So how many hydrogens would you need to counterbalance that? Wow, I need 3. That's excellent. That was probably the hardest one we've done so far on this page. Carbonic. All right, now CO3 is carbonate, but what's the charge on carbonate? -2, so how many hydrogens do you need?
You need 2.
So H2CO3. Okay, next, Claire. Nitrous.
HNO2.
You guys are good. Oops. All right. Not the famous nitrate, but the nitrite, isn't it? And -1, +1. And the, all right, phosphoric acid.
H3PO4.
Now, PO4 is phosphate. Oh, you're right. I was on the wrong one. Sorry. You're right. It is the famous phosphate, and phosphate's -3. I need 3 hydrogens to make it a compound, wouldn't I? All acids are compounds. And when you get the last one, hydrosulfuric acid, no oxygen. There's no oxygen.
So H, then S.
You're getting there. You're very close. Now you look at the periodic table. Hydrogen's +1, but what's sulfur going to be in a compound?
Isn't it
Look at the periodic table. What's sulfur? It's in the same group as oxygen. Way over here.
2?
Yep. So sulfur is -2, isn't it?
So you need 2 hydrogens?
Yes. Yes. What do you think? All I can do is look at your faces. You got to let me know what's going on here. I thought you were doing maybe better than I thought. Better than I thought today. Yes.
I just wanted to alert you to the fact that the page across from the acids we already noticed is a duplicate, but the 2 pages after that are also duplicates.
Okay.
So
If
the
you,
pages that come earlier in the
if
packet.
I don't know how it happened. Let's just say you don't have to do any duplicate pages.
Yeah, so pages that are not duplicates are pages.
Now let me see if we have any pages that are missing.
It's front and back of page 1.
Okay.
Back of page 2 and the front of page 3 and the back of page 3.
Okay. All right. Well, I'll tell you what. I can. I don't really want to reprint these. That's just a waste of paper. So I'm not sure how it happened. So
I just wanted to alert everyone to that so they don't accidentally.
I'll bet by a second time you do the same page, I'll bet a lot of people will figure out, I think I did this page. And then if you did, just cross it out. Here we go. You are ready to learn type 5. Now I'm going to tell you that I can teach type 5 in less than 3 minutes. And you'll say, yeah, you can teach it in less than 3 minutes, but not very well. No, you're wrong. I can teach it in 3 minutes, and I'll go down the row, and almost every single person will get it right. Now, you want to try it? All right. Wait till I'm ready. Okay, is everybody with me on this page? All right, we'll start, and you start the clock at 3 minutes. Now, before I start, let me tell you what type 5 is, okay? The reason I do type 5 last is the only time you look at subscripts to name it. I never look at subscripts on type 1, 2, 3, and 4 to name it. This time, the subscripts are everything. Everybody get that? And let me tell you one more thing that's different, and then I'll teach it to you. These are not ionic. Everything so far has been ionic, plus and minus charges. You get this? These are going to be two non-metals. So when you see two non-metals together, that's when I'm going to use this system here. It is the easiest naming system of all. You know what? I only fear one thing. All the stuff I've already taught you, I hope you don't listen to this and think that other stuff is not true. All the stuff I taught you so far, you remember it. You will only use this for non-metal. You get it? Okay, are you ready? You start the clock. Now I'm ready. Ready? And start. All right, when you have a non-metal and a non-metal in a binary, you'll get something like this. SO2, SO3, okay? Now, if it's non-metal, all I have to do is look at the subscripts. I notice there's one sulfur and two oxygens. You see that? Now, I have to learn these prefixes that mean numbers. Mono, at Disney World, the monorail has one track on it. Mono means one. Di has two letters, and di means two. My tricycle had three wheels, and that's why tri means three. And there's a game called Tetris, and every time a block comes down, it's not one block, it's 4 blocks. And tetra means 4. And a pentagon has 5 sides, just like in geometry class. And hex sounds like 6, and hexa means 6, and a hexagon has 6 sides, and hepta is 7, and octagon, like a stop sign, has 8. You get that? Now, if you know those prefixes, I'm going to show you how to do this. What you do is, you're going to say the name of the first element and the same name second, and it's binary, it's going in an IDE. So what we're going to do is, the rules are, all binary compounds in IDE, they're the only compounds in which you look at, and what you do is, you would never use mono for the first element. So here we go. Here's one. CO2, carbon dioxide. It's the only ones I look at the subscript. Carbon dioxide. What's this one? Carbon, and you would have said monoxide, but chemists said, I don't like saying that, so they say monoxide. They drop one of the O's, don't they? Let's try another one. Sulfur dioxide. Sulfur trioxide. Here's one. Diphosphorus pentoxide. Not pentaoxide, pentoxide. Diphosphorus pentoxide. We'll pick another one. How about this one? N2O3. Dinitrogen trioxide. You see? You don't use mono for the first element, you see, but you would on the second. I'm done. Now, you don't believe me that people understand how to do that. Please do not use this for any other compound except non-metal. And I'm gonna show you some homework here. You watch. You tell me if I'm not true. Before we leave today, you see what happens here. Let's start with Olivia. Are you ready, Olivia? Don't say mono for the first element, but you would have to use mono for the second element. I'm ready. What's CO2?
Would be carbon,
Say it real loud.
carbon dioxide.
Yes, next one, go.
Oh, carbon monoxide.
What is it?
Carbon monoxide.
Yes, next.
Sulfur dioxide.
Yes, next. Up here, Julie.
Would be sulfur trioxide.
Yes, next. Dinitrogen monoxide. Go. Nitrogen monoxide. Go.
Dinitrogen trioxide.
Yes, go.
Nitrogen dioxide.
Yes, go.
Dinitrogen
Tetroxide. Yes, go.
Dinitrogen hydroxide.
Yeah, and we don't say pentaoxide. Pentaoxide. Go. Next one.
Phosphorus trichloride.
Yes, go. Todd.
Phosphorus, wonderful. Phosphorus, pentoxide.
Yes, go.
Nitrogen,
Hydride. Okay, good. Next, go.
sulfur hexachloride.
Go.
Diphosphorus pentoxide.
Now, see this? You know why I kept that to end? Number one, if I had taught that first, please, you'll kill me if you do this. Please don't go back and say, dialuminum trioxide. No. This is a metal and a non-metal. You get that? When's the only time you use these prefixes? Non-metal. Don't ever look at subscripts except that. Have a good weekend. Learn your polyatomic ions, okay? Learn your polyatomic ions. Have a little game. Play a game with it. We're done with all the lessons. We don't take the test till Wednesday. Good job.